We're going to look at moles, and people are often intimidated by this because they don't know what a mole is. So let's get over that right from the beginning. It's just that mole is a number. Just as we use the word dozen to represent 12, we use a mole to represent this big number. And the reason we do this is that dozen is used to make it a smaller quantity when you're talking about things like donuts or eggs. And you can say 4 dozen, and then you do the math and you find out that's 48. We do the same thing with moles, and we will, except we're using atoms, which are really tiny and have a huge number in a tiny sample. So we have to use this really big number to get it down to a number that we're comfortable with. This number here, 6.022 times 10 to the 23, is called Avogadro's number. And just as you can say that a dozen is equal to 12, you can say a mole is equal to 6.022 times 10 to the 23. We only use dozen and mole when we can count things as individual units. You know, we don't use dozen, we wouldn't say a dozen grams. Likewise, we wouldn't use wouldn't say a mole of grams. It's only used where you could actually count individual items. Those individual items in chemistry are either atoms or molecules. Now, this mole is that many items, so if we have a mole of carbon atoms, it's 6.02 times 10 to the 23 atoms. If we have a mole of water, 6.02 times 10 to the 23 molecules of water. Notice here I've rounded this off 1 digit. You can use either number, either 6.02 or 6.022, whichever you prefer. If you have a mole of vitamin C, it's in molecules. So I know, even if I didn't say molecules after the vitamin C, I know vitamin C comes as molecules. So I could say a mole of vitamin C is 6.02 times 10 to the 23 molecules. Okay, these are equivalency statements, and remember that anytime you have an equivalency statement, you can write it as a fraction to do conversions. So I can either write 1 mole over 6.02 times 10 to the 23 atoms, or 6.02 times 10 to the 23 atoms over 1 mole. Notice what digit is with the mole? 1. What number is with atoms? This really big thing. You would never put this really big number with mole, nor would you put it with anything other than atoms or with molecules. If you put it with grams, you're going to be way off. A mole of grams would be something around the size of the Earth, so we won't deal with anything that big. Okay, so to use a mole, all we need to do is do a conversion. It says here how many moles is 2.4 times 10 to the 22 atoms of lithium. So we're going to have 2.4 times 10 to the 22 atoms as our starting point. We don't really even have to have the of lithium there. Our conversion is going to be from atoms to mole. We go ahead and we put our conversion factor so that atoms cancels out, and notice 6.022 times 10 to the 23 is going to be with atoms. Remember, the only unit you ever see this number with is either atoms or molecules. We do our multiplication, and it gives us this number on the calculator, which I then rounded off to this for significant digits. If you're having any trouble getting the correct number on your calculator, I have created an online lecture that says using your calculator with scientific notation, and you can watch that, and I actually show you a picture of the calculator while we do a problem. So go watch that if you're having any trouble. Here are 2 problems for you to try. Go ahead and pause, do the problems, and then I'll go over the problems with you. We start this problem with the given 2.89 mole. Now we need to go from mole to atoms, and remember this number here, Avogadro's number, goes with atoms. So we multiply these two together and we get 1.74 times 10 to the 24. To do this problem, we're going to be using this as our starting point. So 7.2 times 10 to the 22nd. We're going from atoms to mole, so atoms needs to be in the denominator and mole in the numerator. This number goes with atoms. We divide the two numbers. Notice atoms are canceling out, and we get 0.12 mole. Why is this number mole important? It's because we have defined a gram as being 6.022 times 10 to the 23 AMU, or a mole of AMU. So let's just go and look through this reasoning. If I have a mole of hydrogen atoms, then the mass that I have is a mole of 1.00797, which I get from the periodic table. That's the atomic mass of hydrogen, AMU. This is the mass of one atom, average mass of one atom of hydrogen. I can rearrange this and replace mole, because it just stands for 6.022 times 10 to the 23. I can replace that and put that in there. But if I take this number out and put 6.022 times 10 to the 23 with AMU, well, that's just a gram. So when I get through with this, I just have 1.00797 grams. And I can do this for any atom in the periodic table. I can go and look at the atomic mass and take that number and just put gram after it and set it equal to 1 mole. So you have a whole periodic table of conversion factors there. So a mole of any element is going to be the atomic mass in grams. What this does is allows us to go up to a scale, and we can weigh out a particular number of atoms by using the mass of those atoms. It's very convenient. So if we're using a mole and mass, this is going to be the conversion factor that we use. A mole of that element is the atomic mass in grams. And I'll use a fraction to do the conversion factor. Here's an example. I have 0.0040 moles of lithium. I can go from mole to gram by looking up the atomic mass of lithium. So that goes with gram. I multiply through and I get a mass of lithium. So I can actually say from this mass, I have a certain number of moles of lithium, which then can tell me how many molecules or atoms I might have of that. Go ahead and try these problems on your own, and then resume after you've tried them. Okay, if we have 0.2 moles of calcium, I'm going to go from mole to gram. I look up in the periodic table and I see that the atomic mass of calcium is 40, so a mass of 1 mole is 40 grams. Of course, I have some more digits there. I multiply through and I get 8 grams. How many moles is 5 grams of iron? Well, here I'm going to go from gram to mole. I look up the mass of iron and I see that it's 55.849. I divide through and I have 0.090 mole. Now here, 250 atoms of gold, you might have had some trouble figuring out how to get to grams, but remember, we can go from atoms to mole, and then we can go from mole to gram. So what number belongs with atoms? Remember, that's 6.022 times 10 to the 23. How many grams what number goes with grams? Well, you look that up in the periodic table for gold, which has a symbol of AU. It used to be called Orium. That's why it has that symbol. And you will see that it is 196.97. I enter these numbers in. I take 250,000, divide by this number, and multiply it by this number, and I get 8.2 times 10 to the minus 17. Now, we have this relationship between moles and number of atoms and moles and grams. Realize this is how they're connected. You can look at this and call this a unit map. And if you write this down on an index card and keep it with you when you're doing problems, you might have an easier time thinking through the problems. For instance, let's say I'm give you grams of something and I say how many atoms are in that. Well, then you can see you need to convert gram to mole and the mole to number of atoms. And you look up the atomic mass and you then have your number that goes there. And you always know that a mole is equal to 6.022 times 10 to the 23 atoms. Or if you're dealing with molecules, you would put molecules after that. What's another example? I give you number of moles and ask you what mass that is. You can see you can go from mole to gram directly. And so you're just going to need this equivalency to construct your fraction.